Hello, everyone. Thank you for having me. I'm Ross Upton. I'm founder and CEO of Ultromics. Little introduction, little background on myself. For those that don't know me, I'm a cardiovascular scientist by training and an echocardiographer before I founded Ultromics and spun it out about 5 years ago. There we go. So Ultromics is a spin out from Oxford University from my PhD. We developed automated software to analyze echocardiography. We have 3 FDA clearances now. We collaborated with the Mayo Clinic and Oxford University to do so. And in doing so, we've built AI in a way that is always set against patient outcomes. So we're never in the business of trying to repeat what the clinician does. We're always trying to use the AI to predict patient outcomes. And we now specifically have a focus on heart failure. And I'll show you what that looks like. These are some of our investors and partners and customers. Just to say that we have about 20 health system customers across the US at the moment, which means that we're processing about 2,000 echocardiograms a week, many of which are for the indication of heart failure. So on an ongoing basis, we're collecting enormous amounts of echo data and specific to heart failure. And this is what the product looks like. As mentioned, we've got 3 FDA clearances, and we've recently received an FDA breakthrough status for our heart failure prediction algorithm, our HFpEF prediction algorithm. We do both automated quantification and also disease prediction from the echo image itself. The platform sits in the cloud, so we ingest echo images from PACS systems, automatically analyze them, provide quantification, things like ejection fraction, strain, but then also diagnosis, sort of detection algorithms for specific diagnoses. And we've gone a step further now in development, which is trying to look at the different phenotypes of HFpEF, which is why we were so interested in this project. Our thesis has been, echo's been great as a first-line diagnosis for heart failure, but it has some serious limitations. And so can we use AI to try and dig down deeper into the different phenotypes of HFpEF? And yeah, this is just an image showing that we're trying to also unblack box and show where the AI is looking at, see if we can discover what the AI thinks is relevant to the HFpEF diagnosis and phenotypes. And so you can see on the bottom middle tile there, this is what we call AI lens, where it examines, where it shows where the AI is looking at on the left ventricle, what it thinks it's picking up that is relevant to HFpEF. And what we found is it often picks up the medial and lateral kind of E' area, which is interesting. It's consistent with measuring diastolic dysfunction on echo, but it also picks up things that you may not consider, and also things relevant to different phenotypes. So LVH, amyloidosis, regional wall motion abnormalities consistent with coronary artery disease, and also it often picks up pulmonary veins as well as an area of interest. And so what are our interests? Well, as I mentioned, we're developing a more phenotyped heart failure product. We want to continue building out this product in line with the goals of this project. We're specifically interested in matching our device to the new therapies that are coming out for HFpEF. We've already got one initiative underway to try and link some of these outputs to the SGLT2I therapies that have come out, but we want to continue to do so. Our thesis is there's no point in building things if it's not matched to a therapy. So we're building the software in a way that it matches to heart failure therapies. We want to stop misdiagnosis of HFpEF. One of the reasons for developing this platform was because of the misdiagnosis of HFpEF, but often just the uncategorized diagnosis of HFpEF through current clinical algorithms. I know in literature it states somewhere between 30 and 50% is unclassifiable using the standard clinical algorithms. In our data, we've seen it up to 61% as unclassifiable from an echo, and thus means a lot of patients then have to go on for invasive tests like right heart caths, And one of our goals is to be able to create a better and more accurate phenotyping at the level of the echo. And moving on to how we can help out with the project. Well, we've got advanced AI skills, we've got an advanced AI team, we've got lots of engineers and clinical scientists that can help support from the AI side. We process tons and tons of data every day. We move echo images around the world and to centralized locations, quantify, annotate them, and put them in databases where they're readable. So we already have the infrastructure and everything set up to do that. We can obviously help out core labs, make measurements, screen for HFpEF. We can use the GradCam, the color mapping there, to see if we can match phenotypes to the images of the echo. And yeah, we've got we can leverage our software as a service infrastructure to route those images around and also contribute to the data pool with the amount of data that we're processing on a daily basis. So yeah, that's us, and feel free to come and chat to me if you want to know any more, but thank you.